Hi everyone, my name's Alec Thomson. I'm a postdoc at CSIRO, and I wanted to share my results looking at the brightest polarized spot in the southern sky at 408 megahertz. Using the Global Magneto-Ionic Medium Survey, which is an all-sky polarization survey with parks from 300 to 480 megahertz, we found an unusually bright polarized spot in the southern galactic hemisphere, which we call G150-50. What's unusual about this spot, other than its high polarization fraction, is that as we look to higher frequencies, we see that this spot no longer appears. And this is a continuous fact. So across a large range of frequencies, we see that as we go to higher frequencies, it in fact depolarizes. And this is typically in the opposite direction to what we typically expect from this kind of object. And so we've attempted to model this. And we find that if we attempt to fit a model across the entire band from GMMs all the way up to 30 gigahertz, we find we need something exceptionally complex, far more complex than what we'd reasonably expect from the interstellar medium. However, if we fit to just the longest wavelengths, where we actually expect there to be a relationship between the distance and the emission. So at the longest wavelength squareds, we're actually only seeing the stuff that is close by, whereas the shorter wavelength squareds, we're seeing along a further depth. We can fit a much more simple model to the stuff that is just more close by. Further, if we look at the Faraday depth structure, which tells us about the structure in the magneto-ionic medium just within the G-MIMS band, we find we can model this as an expanding shell magnetic field structure, a relatively simple one, and recreate the same Faraday depth structure that we observe. And so we believe that we now have a model for the radio loop 2 as an expanding shell, and its projected magnetic field lines on the sky are producing this object. I'm happy to take any more questions throughout the conference or later on. Thanks so much.